Okay, we're going to go over the FRQ. It's from the 2009 AP exam. It's question number 5, so it's a no calculator question. So we have a chart here with various x and y values, and for part A, it says estimate f prime of 4. Show the work that leads to your answers. So f prime means slope, and we only know points close to 4. The closest we can get is 3 and 5. 4 is right in between. So if I use those points, 3, 4, and 5, negative 2, I can find the slope between those 2 points using my slope formula. And that gives me negative 3. So that is the closest estimate I can get to the slope at that point. Now, if it asks you to justify your answer, you want to make sure you use calculus terms and you want to say the right theorem. So anytime you use the slope formula, you're going to say it's by the mean value theorem. Okay, so that was worth, I have it marked here, 1 point on the AP exam that year. So for part B, evaluate the integral from 2 to 13 of 3 minus 5 f prime of x dx. Show the work that leads to your answer. So I'm going to evaluate this integral. I'm going to write it down first. And I'm going to work from left to right, taking the integral. So the integral of 3 would be 3x, minus the integral of f prime would be f, so 5f of x. And we're evaluating this from 2 to 13. So next thing we're going to do is plug the numbers in. I'm going to plug the 13 in first. And then minus, I'm going to plug in the 2 next. And I can get these values from our chart. So this would be 3 times 13 minus 5. F of 13 from the chart is 6. 3 times 2 is 6 minus 5. F of 2 from the chart is 1. Now in the AP exam, you do not have to simplify, remember, so you can stop right there. If you do want to simplify that, I solved it earlier. The answer is 8. Okay, so we're going to go to part C next. So part B was 2 points, one for finding the integral and then one for finding the answer. So part C, use a left Riemann sum with subintervals indicated by the data in the table to approximate the integral from 2 to 13. Show the work that leads to your answer. So I'm just going to recreate this list here. We've got our chart. We're going to use a left Riemann sum. So that's a rectangle. I'm going to start with my first section here. So I'm going to write down what I'm doing. I'm finding the integral from 2 to 13, f of x dx. So we've got a rectangle. So the base of that rectangle would be 1, right? The distance between 2 and 3 is 1. The left height is 1. My next rectangle, distance between 3 and 5 is 2. The left height is 4. The third rectangle, base would be 3. Left height is negative 2. And the fourth rectangle, base would be 5. The left height would be 3. So again, we could stop there. We do not have to simplify. So if you do end up simplifying though, if you want to check it, the answer is 18. So that would be 2 points. 1 point for the answer and 1 point for taking a left Riemann sum. Okay, last section, and this one is worth 4 points because there's lots of stuff going on. So part D, suppose f prime of 5 is 3 and f double prime is less than 0 for all x in the closed interval from 5 to 8. Use the line tangent to the graph of f at x equals 5 to show that f of 7 is less than or equal to 4. So that's the first part of the question. I'm going to stop there because the second part's like a part B, technically, of the part D here. So I'm going to write my equation of a tangent line. So I need the slope, which I already have. Slope is 3. And I need my point, which is 5. And if I use my chart, the y value that goes with 5 is -2. So I'm going to write my equation of a line. Y plus 2 equals m x minus 5. Okay, so we're checking this right here. So meaning I'm going to plug 7 in, and we should get something equal to or less than 4. So I'm going to plug in 7 for x. That gives me 2 times 3, which is 6. Y would equals 4. So the question says, show that f of 7 is less than or equal to 4. Now something they give us that we haven't talked about yet is right here. They tell us that the second derivative is less than 0. The second derivative, remember, tells us about concavity. So if your graph is less than 0, that means your graph is concave down. And we just found a tangent line. So let's say this is 7. The tangent line no matter where your point is, the tangent line actually sits above it, except for where it meets perfectly at it. So if we use this tangent line to estimate something, let's say we want to estimate the y value at 9. Here's the actual answer, but the tangent line would be up here. It would actually be an overestimate because the graph is concave down. So no matter what, anywhere on our curve is always going to be less than the tangent line. So f of 7 is our actual answer. 4 is the value that we're proving it's less than or equal to. So it has to be less than or equal to 4 because the line is actually under the tangent line. So how we would say that is f of 7 is less than or equal to 4 because f double prime is less than 0, or you could say that the graph is concave down and the tangent line sits above the curve or lies above the curve. So that would be our complete explanation. Okay, we're going to do the same thing with the second part of this. So for the second part, it says use the secant line for the graph of f from 5 to 8 to show that f of 7 is greater than or equal to 4/3. So a secant line crosses at 2 points instead of 1 point. So if I draw a graph that's concave down, our secant line, I'm just going to pick one randomly, would cross through 2 points. So the 2 points that they give us is saying we're going between 5 and 8. So I'm going to pull those 2 points from my chart. The y value that goes with 5 is -2. The y value that goes with 8 is 3. So I'm going to find the slope. 3 plus 2, 8 minus 5. So 5 over 3. I'm going to pick one of those points. I'm going to just use the first one to write an equation of a line. Y plus 2 equals 5/3, x minus 5. And what are we checking? I'm going to go back to f of 7 is greater than or equal to 4/3. So I'm going to plug 7 in. And I'm going to solve. So 7 minus 5 is 2. 2 times 5/3 is 10/3. If I subtract 2, that would be 6/3. So 10/3 minus 6/3 is 4/3. So let's look at our graph here. F of 7, let's say this is f of 7. If we use our secant line as an estimate, though, it would be an underestimate. So we just proved that f of 7 has to be greater than or equal to the 4/3. So it could be equal to it if it actually met right up, like let's say the point was here, then it would be equal, but it could also be greater than. So to write that out, we would say f of 7 is greater than or equal to 4/3 because the second derivative is negative or concave down, and the secant line lies below the curve. Okay, so that concludes the explanation for that FRQ.